In this unit, we're going to start to talk about measuring angles. So the first definition I want to give you is just the definition of an angle. An angle is a geometric figure formed by two rays with a common endpoint. Notice the notation I always use for angle is this figure that looks like a little angle. The sides are two rays, so ray OA and OB, and the vertex is the common endpoint, so it's point O. Naming the angle. There are many ways that you can name this angle. One way that you could name this angle is by putting numbers inside of here. 1, 2, 3. So this angle could be angle 1, this one's angle 2, this one's angle 3, and we could write that angle 1, angle 2, angle 3. Other ways you name angles is angle 1 is also denoted as angle AOB or angle BOA. O, the vertex, always goes in the middle. Angle 2 is noted as BOC or angle COB. And lastly, angle 3 would be angle COD or angle DOC. A protractor is how we measure an angle. You've probably used one before, and just as a reminder what it looks like, it's a semicircle and it's got angle measurements around the outside. The degree is the unit of measurement that we measure angles in. There are interior points to the angle and exterior points, so these are all considered interior. They're on the inside, and then these are the exterior points. Congruent angles are two angles that have the same measurement. So there's two ways to denote this. You can use the congruent sign between them, or you can use the equal sign. Notice if you use the equal sign, you have to talk about the measure of the angle. So the measure of the angle might be 35 degrees, equals 35 degrees. If you're talking about congruent, we're talking about the actual angle. So we do not use the little m in front of it. Protractor, the measure of the angle is always positive. I want to make sure and denote that. That's the protractor postulate. Classifying the angles. Angles are classified as acute, right, obtuse, or straight. An acute angle is less than 90 degrees, so it looks like a small angle. It opens real small, like a mouth of an alligator. Where a right angle is denoted with a little box on the inside, and it's perfect square. That is definitely not a perfect square there. And then an obtuse angle is large. It opens really wide. And a straight angle is exactly 180 degrees, so it makes a straight line. Angle addition says that if you have an angle AOC, so we have this larger angle AOC, AOC, and I have OB that cuts in the middle of it. If I add the small angle AOB to this small angle BOC, it will equal the entire angle. So let's look at an example of that. If I have the AOB is 3x plus 11, and I know that BOC is 5x minus 5, and I know the entire thing is 6x plus 18, I can write an equation to solve for x. I could say the little angle 3x plus 11 plus the other little angle 5x minus 5 is equal to the big angle 6x plus 18. So when I combine my like terms, I get 8x. Combine my 11 and negative 5, I get a 6. I subtract 6x on both sides. I'll get 2x plus 6 equals 18. Subtract 6 from both sides. I need to come down here a little bit. I get 2x equals 12. So my x value is 6. That allows me to plug that back in for AOB. AOB is right here. So I'd plug in 6 for my x value and solve. That gives me 18 plus 11, which is 29. One more example here, and it's the same type of setup. So I have the small angles 4x minus 3. The big angle, or the little bit bigger one here, is 5x plus 10. And then the entire angle is 6x plus 13. Again, I'm going to set up an equation that says the smaller angle AOB plus the BOC is equal to AOC. So when I combine my like terms, I get 9x, and then here I get a positive 7 equals 6x plus 13. I'll subtract 6x. I'll get 3x plus 7 equals 13. I'll subtract 7. I get 3x equals 6, and x is 2. Then that allows me to find AOB. AOB is right here. 4 times 2 minus 3. That gives me 8 minus 3, so it's 5 degrees.